looking at some new problems from CSCS sheet. Just a second, let me disconnect. So we'll be moving on towards new sheet. Till now we were doing some questions from the TLE eliminator sheet. But let's move on. I mean, we'll still do some questions from there, but we'll also introduce these new questions from CSS. What's different is that this will have far too many less test cases to find the logic. Okay, there will be the question itself will tell you the whole picture. So the question says that you are given a grid of n cross m where each cell contains one of the four letters A, B, C, D. For each cell you must change the character to A, B or C or D. The new character that we are going to replace instead of the previous one present there must be different from the old one. That means whatever character is present at a cell, we should replace it with another character which is not the same. And also your task is to change the characters in every cell such that no two adjacent cells have the same characters. So we must change such that no two adjacent cells have the same character and it is not equal to the previous character which was present there. So let's look at how we'll solve this. I'll assume a grid to be a small grid of, let's say, 3 cross 3, right? So for each grid, let's say I want to fill this position in the middle, this position. So this position, what all restrictions do I have? That the adjacent cells should not be equal, right? Let me name, let's say the element here was, I'll use another way, just a minute. So this was our 3 cross 3 grid. So I'll just name the characters present here as A11, A12, A13, A21, A22 and A23. Similarly here also. So what are the conditions on A22, the element here? What are the conditions or restrictions for this? It is that it should not be equal to any adjacent of the character. So A22 has 4 adjacent characters, right? So it should not be equal to either of A12. I'll just instead of writing the elements, I'll use a general reference. It should not be equal to the element above it, an element below it, an element to the left of it, or the element to the right of it. And also it should not be equal to the element itself. That means the element at this position should not be equal to A22. Let's say A22 was, I'll use an example, right? Let's say the characters were A, B, D, D, A. These were the characters and the number itself, right? So for this cell A22 should not be equal to the character above it. Which is the character above the cell A22? It is the character B. So it should not be equal to B. Then again the character below it. The below it character is character D. These are the references I am using. Okay, these are not the actual character. These are the references I am saying. That above, below. Then the next one is to the left of it. Towards the left of it, A is present. So A, then towards the right again A is present, and the number itself. So the number itself at this position for the given array was D. So it should not be also equal to D. As we can choose the character from A, B, C, D, and the restrictions are the character should not be equal to any one of these. So what option do we have remaining? That A22 should be equal to C. So in our new transformed array, I know that the position 2, 2 will be filled by the character C. Here previously it was D, it will be now filled with C. That is what the question is asking us. So how can we do this? There is no restrictions on the number of A's, number of B's, or number of C's or D's which we can fill here. We just have two restrictions, that for each in the final grid, each cell should not be equal to the character present at the adjacent of it, and also it should not be equal to the cell character itself in the original given grid. These are the two constraints. So we'll start filling it greedily. We'll just, let's say this is the grid n cross m. The final grid will also be of n cross m. So we'll start greedily filling this up. So the first element, what all restrictions does this have? It will be that it should not be equal to the character itself which was in the original array. So in the first place the original character was, let's say, a11, so it should not be equal to a11. Then it will, what it must do, it must check to the character at the left of it, but there is no character to the left of this first cell, right? So that condition does not hold. Then again, the character above it, for this cell the character above does not exist, so that is also invalid. Then again, the character below the given cell, for this first cell, now I am filling this first cell, right? What should be present, what should we put value here, what value should we put here? So these two cases are invalid because there does not exist a cell to the left or above it. For the cell below it, we still haven't yet reached, we are fielding, just a second, we are finding the values step by step, right? We are going greedily from left to right, from top to bottom, one by one we are putting in the elements, right? So the element here, then we'll fill the element here, then we'll fill the element here. So we are greedily going through the array, going through the grid. So we have not, when we are finding the character at the first place, we have not yet filled the value at the second or the cell beneath the first one, right? So as there are no characters present here, we don't need to worry about the constraint between these two. Why is that? Because here we can fill according to whatever necessary condition is there. When we come here, we'll worry about the cells, about these cells which are not yet filled, when we will fill them. Okay, so we'll worry about these cells later. And why does it work that after we can directly skip these two restrictions now and worry about them later? It's because these have free restrictions, right? The only restrictions for them is to check the above, below, left, right, and the character itself in the beginning array. So when we reach here, we will check them and accordingly fill the appropriate character. So if we appropriately fill the character here, then that's correct, right? That's the correct approach. It will check all the restrictions when we come here. So when we are at the first cell, there is no need to worry about the restrictions with the unfilled characters, only with the filled ones. But in this case, the first cell is at the corner, so there is no cell above it or to the left of it. But the other condition is that it should not be equal to the value in the previous grid, right? So the previous grid, let's say it was a11 value, so it should not be equal to the value here at the first grid. So that is the only condition. So among A, B, C, D, all these four characters, for the first grid, all characters are accepted except the one which will be in the original given grid at the first position. That was the only restriction we have found here. Then if we move to the second position, now let's say a11 in the original given string, I'll just fill this array. Okay, it was A, here it was C, B and D. Okay, I'll generalize it. It is more easy if we generalize it. So according to a, just a minute, let me write, this is, let's say, a given cell. There is a cell above it, there is a cell towards the left of it, a cell towards the right of the given string, a cell to the bottom or the below it, and there is also one cell in the original grid which is at the position itself. So if we are worried about this position, the character of that cell in the original grid is, I am representing it by the I cell. Okay, So let I be the cell in the original grid. So for filling each cell, this is a general cell, this is a general cell. For each general cell we need to check all these conditions, that these two, these two, these two, these two, and this I, this should not be equal. So how many constraints do we come up with? We come up with 1 2 3 4 5 constraints, right? We come up with 5 constraints. And when we are filling it, when we are filling a grid greedily from left to right, top to bottom, one by one, using a manual way, by checking each time what the cell restrictions are, when we are at this position, there does not exist top or left, right? The two conditions will get invalid. This condition of this being unequal and this should being unequal, these two conditions get invalid. So remaining conditions are 3. There should be 3 restrictions present. I'll just represent the restrictions, okay? So this cell has 3 restrictions. Then when we move on to this cell has a left, right, bottom, and the number itself. So this cell, but as you can, okay, in this case also there are not 3 constraints, because this constraint is not present because there is no cell towards the left of it. Similarly, there is no cell at the top of it, so 2 constraints are invalid. Again, the constraint of the cell below it and the cell to the right of it is also invalid, because there is no character filled here yet. We have not filled the character yet. It can be anything. This can be element X, character X. So if we put anything here like A, B, C, D or anything, according to what we put here, when we move on to the next character, when we'll move on to element X, this X will be transformed according to this what we have put here. So we don't need to worry about the constraint between these unfilled values and the cell we are choosing currently. Got it? So we don't need to worry about this. So these two and these two, the only constraint remaining is 1 constraint. So this first cell will have only 1 constraint. Then when we move on to this cell, what character should be here? As this cell is filled, there is 1 constraint from here, right? There is 1 constraint from here. Then there is no cell above it. Then the cell below it and the cell towards the right of it are empty, so they don't hold any restriction, because they can be anything according to the given circumstance. So we can put anything here, X. So only 2 conditions. The one that is the number itself, in the original grid, the second character, it should not be equal to that, and this should not be equal to the cell adjacent to it, which we have filled now. This is a filled one, right? So this constraint holds. So there are 2 constraints for this cell. Similarly here also there are 2 constraints, and if we just write this, just a second. Yeah, when we come here, as you can see, towards the left of it there is a filled character, so there is 1 constraint coming from here, and there's another constraint coming from the number, the cell position itself, the cell position of the original grid. The character at that cell should not be equal to the character here, right? So 2 constraints again. Now similarly, when we move here, there is a cell above it, so 1 constraint from here. There is no cell to the left of it. The bottom and right cells are empty, and there is only the cell itself condition and this condition, so 2 again here. Now as we move on to this condition, in this condition, this is a general condition, right? So when we are filling this grid, there are only 2 cases. One, if the cell is at the edge, and the other cases is the cell is in between other cells. If the cell is on the edge, because of the grid restriction, that grid is only limited till that value, so the restrictions get reduced from 5. But let's say we are in the middle of the cell and all the cells there are many cells surrounding the selected cell, right? So in this case, how many conditions can we come up with? So the first condition will be this one, that this cell element should not be equal to the element above it. So one condition. Then again to the left of it. So two conditions. And then the third one is the value itself from the original grid, right, at the position itself. So three conditions. This fourth and fifth cell are empty. Like I said previously, they hold the value x and they can change accordingly when we move on to them. So they can be anything, so we don't need to worry about them. So we come up with three constraints. Similarly, three constraints, 3, 2, 2, 3, 3. You can manually find this out. It will come out to be like this only. I'll write it even if no one cares. Just a minute, I'll complete it. 1, 2, 2, 2, 2. So in a grid, the maximum constraints for a cell that can be imposed are 3 maximum, and the minimum is 1. And we have options A, B, C, D. Right, the maximum 3 constraints can be there, and maximum different constraints can be also 3, right? All these 3 can be different. In this case, as you can see, the 2 constraints, the cell to the left of it and cell to the right of it, for a given cell, for a cell towards the left and a cell towards the right, both are A. So that means the constraint is repeated, right? Constraint is repeated. But what if all the constraints are different? If all the constraints are different, there can be maximum 3 different constraints. That the cell should not be equal to, the cell, let's say, should not be equal to B, should not be equal to A, should not be equal to C. So as you can see, as there are maximum 3 constraints which can be different, there is always a possible answer present. For a cell, there is always a possible value that we can put on the cell position according to which all the constraints are followed. And if they get repeated, then as usual there are many options. You can choose either of A or B, or either of A or B or C. But maximum different constraints can be 3. So there will always be one of the characters remaining, one of the characters which will fill all the constraints, which will satisfy all the constraints. So we just need to implement this now, that for each cell it will check to the cell towards the left of it and towards the cell above it, as the cell below it and cell to the right of it are empty, because we are filling it from left to right and after that top to bottom. That means we are filling it one row at a time, and then after one row we'll move down the column, right? So we are filling the grid from left to right, top to bottom. Okay, got it? And due to this pattern, we need to only check constraints for the number itself. That means the position itself. That what I mean to say is this I condition, right? The I condition is the cell should not have the value which was previously present at that position. So we need to check for that I constraint and the constraints for the cell above it, and for this cell, let's say for this cell it will be constraint I, the constraint above it, and the constraint towards the left of it. Because when we are filling this, the constraint towards the right and constraint toward below this will be invalid, because there are no element present here and it can be anything. So we'll check these 3 conditions, and after checking through the 3 conditions, we'll always have a character at the end which will remain with us, which can satisfy all these conditions. So let's look at the implementation. The implementation part was quite easy, but still I got a TLE error. I'll show you why. The first one, yeah, see, I got a TL here. So what I did was a 2D array of the characters, and for checking the constraint at each cell position, I created a new string, let's say string r abcd. So these are the possible values. Then I use the constraint that if there is a cell towards the left of it, I minus 1, I is the row, right? So if there is a cell, if I minus 1 is positive, that means it is a valid index. That means there is a cell towards the left of it. Then what I'll do, from this string abcd, I'll remove that character which is present at the position c of I minus 1 comma j. What this does is replaces that with nothing. That means I'm just deleting it. From this abcd, I'm deleting the character which is present at c of I minus 1 and j. And I'm just checking here that if I minus 1 is a valid index. Similarly, for a cell above it, it will be j minus 1. Sorry, this is towards the left of it, and yeah, the cell above it is a j minus 1. And after checking the left and the top, we need to check for the value itself, right? The I condition. What is the I condition? That the cell should not have the character which was previously present there. So what that means is that, sorry, this was the I minus 1, this was the j minus 1, and this condition is for the I condition, the I constraint. The I constraint is that on changing the value, it should not be equal to the I and the previously present character there, right? And I'm changing that character to whatever, let's say the original string is abcd. Then what I'll do, I'll check through the three conditions. This is condition I, the condition above it, and the condition to the left of it. So this is the condition I. Let's say this was a character A. Originally the character at index I comma j is A. So we remove A from this string. It becomes BCD. Okay, BCD. Now string R is BCD. Then I check for what is the value at the left of that, at the cell towards the left of the selected cell. So let's say it was C. So now we remove C from the R string. We had BCD as the R string. Now if we remove C, it will be B and D. The string R will be just BD. Then I'll check the third condition, which is the cell above it. We'll check the value of the cell above it and remove that from the answer string. So if it was, let's say, D, then from BD, D will get removed, so only B remains. And finally this B, as this B is not yet removed after all these three conditions are valid, that means this B is an acceptable character at that position I comma j. So I just fill that at the I comma j, and I wrote this r dot caret at 0 because if any of these conditions get repeated, that means lesser number of characters will get deleted. If there are three different characters get deleted and only one character remains. So we'll directly print that caret 0. But if, let's say, some characters repeat, that at the cell towards the left and at the cell above it there are same characters, so only 1 and 2 characters are erased, right? So let's say C and D are erased, A and B remain. So the answer is that either A or B, both works, but I am selecting caret 0 as there is no reason, because it becomes simpler. So I am just selecting the caret 0 because there will always be a string, a character left, right? Remaining, there will always be a character remaining. That is what I am trying to say. So I wrote caret 0. In this case, A and B were remaining. A and B were the possible answers, and I'm printing. I'm at the I comma j. I'm filling in the value at caret 0. That is A. So that is correct. And then I'm printing it. So what happens? What is the time complexity? The question was, just a minute. Let me open this in a new tab. So the question was, there are 500 rows or 500 columns maximum, and the time limit is 1 second. So according to my solution, here it is n square, right? N square and again n square, so 2n square basically. So for 2n squares, that is 500 times 500, that is 25,000, or what, 2,50,000, right? Whatever it is, I'm getting a TLE, right? So this is not the optimized, this is the most brute force way. Even though this is clever, this what should be the acceptable character here, this method is clever, but I'm using two for loops for checking that and for printing that also. So this is an inefficient way. That's why I was getting TLE for the cases which were of the 500 size, the maximum size. So for optimization, what I tried was, instead of taking it in an array of, because what I'm doing is I'm limiting the CPU, right? CPU is insanely fast. Okay, the only thing we limit is by introducing different input output or slower input output methods which are suitable for humans. But CPUs are insanely fast, they can do very fast calculations, but when we force them to use slower methods, the answer will be slower, right? So instead what I did was, the input, I took them as an array of strings. So each line is a string and each cell is denoted by this array of that string and the character of that string present in the string. Okay, so each line, let's say there is a grid, this is a grid, so each line is a different string element, right? This is a string element of index 1, string element of index 2, string element at index 3. I have created an array of these string elements, and for accessing the cell, that is, I am accessing a character of that string at index I. So I use that method, and I use a string builder using the same concept, that let an array of all the possible answer A, B, C, D, and if this color passes through all this text, all these conditions, then we need to add it to the answer, or else we need to continue, that is, we need to change the color. So the color will, if it was A and if this was the condition that it didn't satisfy, then it will be continue, so it will change the color, it will move on to B. Once all these conditions are passed, then and when only it moves on to the filling up part. This answer, I have also filled up the answer as a array of strings, right? So that was it. This was the optimized solution. The question was of a medium difficulty, I would say. The part that if the character is, let's say this was the question, right? Let me erase this. So when we are filling up this array, we have come till here. The thing that was important to notice is that when we are filling a character at this position, as we have filled this character, that is the above it, so this constraint holds true. We need to follow a constraint here, then again we need to follow a constraint here. But as there are no values here, it can be anything, because when we move on to this, when we move on to filling this, we again check for the constraints, and according to that constraint we fill this value y. So this y will be the most optimal solution. We don't need to worry about this. So when we are filling this x, we need to consider that this y is appropriately filled already. This y is appropriately filled already. So we don't need to check the constraint here and here. Got it? So that was the most important observation here. Okay, thank you guys.